Slow fade in, deep tone. At sea, the vastness hides secrets. A warship slips its transponder, cuts its lights, sails into contested waters. Above it, 500 miles overhead, a silent sentinel watches. A radar image flickers, an algorithm flags movement. Within minutes, a naval command post lights up. A target has been detected. Welcome to the age where navies track enemy ships not just over the horizon, but from space. Pause. In this film, we will explore how modern navies turn satellites into ocean watchers, how hidden ships are revealed, and how the rules of naval warfare are changing beneath the constant eye of space. Welcome to the Navy Chronicles. The ocean has always been a domain of mystery. For centuries, navies prowled the waves, relying on eyes, radar, sonar, patrols. But the new era began when the first reconnaissance satellites lifted above the Earth. Over time, navies realized the sea doesn't end at the horizon, space can see further. Today, naval surveillance is no longer just about ships and aircraft. It's about constellations of satellites, sensors, data networks. Cooperative systems, such as the Automatic Identification System AIS, allow vessels to broadcast identity, location, course. But what of those who don't broadcast? The dark ships? Enter space-based surveillance, optical and radar imaging, radio frequency emission detection, machine learning analysts. The battle space now covers surface, subsurface, air, and space. The stakes are high. A missed ship in a choke point can mean surprise torpedo attack. Detecting illegal vessels before they strike pipelines or deploy mines can prevent conflict. The foundational question, how do navies track ships from space? Let's break it down. Many vessels voluntarily broadcast their position, course, and speed via AIS, originally designed to prevent collisions, but now a key tracking tool. Satellite receivers pick up these AIS signals from orbit, enabling coverage far beyond terrestrial stations. This gives navies and maritime authorities a global view of cooperative traffic. When combined with basic ship registry data and vessel type, this builds situational awareness. But only cooperative vessels. What happens when AIS is switched off or falsified? That's where the next phase begins. Surface vessels may attempt to evade identification. They may switch off AIS, alter transponder identity, or operate in remote zones. Satellite optical imaging and synthetic aperture radar, SAR, provide non-cooperative detection, day-night, many weather conditions. For example, China's radar imaging satellite captured U.S. warships with high resolution. Companies like Airbus describe how satellite imagery plus AIS matching reveals dark targets, vessels without AIS or abnormal behavior. The workflow, satellites, optical/SAR, scan large ocean areas, image candidates, data matched with AIS database, anomalies flagged, intelligence analysts evaluate for action. Example, the Italian firm Leonardo SPA launched SE on a Sea platform. It pulls satellite data, AIS, big data analytics to track vessels globally in near real time. Another layer, ships emit radio frequency signals, navigation, communication, radar, power systems. Even if AIS is off, these emissions betray them. The company Unseen Labs, via nanosatellites, detect RF emissions and geolocate vessels with kilometer-level accuracy anywhere. This is a game changer. A ship trying to vanish still emits electronics, and a satellite may detect its signature. That gives navies an edge. For navies, space-based RF detection complements imaging and AIS to triangulate suspicious vessels, enabling tracking even when other systems are denied. Vast volumes of data flow from satellites, sensors, ships. Modern navies must fuse cooperative AIS, optical/SAR imagery, RF signatures, patrol data, sensor webs. This fusion enables maritime domain awareness, MDA, knowing what's happening on, above, and below the sea. Artificial intelligence and machine learning play increasing roles, identifying dark ships, pattern recognition, anomaly detection, reducing human analyst burden. For instance, MHI's AIRIS satellite uses onboard AI to detect ships and send only relevant data. Narration. Imagine dozens of satellites scanning every hour, algorithms flagging a vessel deviating from normal route, an RF signature appearing where none expected, a SAR scan matching no AIS. A naval command lights up. Target acquired. Then the human decision chain. Naval intelligence assesses risk. Command may dispatch a patrol craft, aircraft, or just monitor until the vessel enters territorial sea and can be inspected. This isn't sci-fi, it's operational now. The Indian Navy, for example, uses spaceborne sensors as part of its ISR network and maritime domain architecture. Let's envision a scenario. In the Indo-Pacific, a warship of Nation A sails into a corridor near an island chain. It turns off its AIS. Satellites detect a ship via SAR and RF emissions. The AIS database shows no broadcast. Algorithms tag it as dark vessel. Command issues a patrol aircraft to intercept. The vessel is intercepted before it deploys mines or conducts reconnaissance. Such scenarios underline the strategic value. The ocean is big, but space makes it smaller. The ability to track enemy ships from space shifts the naval balance. Surprise attacks become harder, hidden approaches more difficult. Surface forces face new visibility. For smaller navies and maritime nations, space-based surveillance means greater deterrence capability and less reliance solely on ships and aircraft. But there are limits. Submarines remain far harder to detect from space. Weather and revisit time limit optical systems. Adversaries may spoof AIS, jam RF, use stealthy designs. Analysts debate how good is good enough. The legal regulatory domain. Satellites tracking vessels raise questions of sovereignty, international maritime law, especially when detecting vessels in international waters or exclusive economic zones. Wider impact. Not just warships, this tech aids in combating illegal fishing, trafficking, environmental monitoring. Space-based surveillance is dual use. In sum, modern navies are no longer blind beyond the horizon. They are networked into space. Narration slower, reflective. From the surface of the sea to the orbit of satellites, the theater of naval warfare is expanding. The silent watch of space means that hiding at sea is harder than ever. For navies, the age of the hidden ship is ending. Yet this doesn't mean navies become obsolete. Rather, the new edge lies in integration. Ships, aircraft, space sensors, intelligence, human decision makers. As one admiral put it, we sail on the sea, but our eyes are in space. The true story of modern naval warfare is no longer just about steel, diesel, and waves. It is about electrons, data pipes, and orbiting sensors. And in this age, the one who watches from above may decide the battle below. Pause. Because in modern naval operations, if you cannot be found, you cannot be deterred. And if you can be found, you must survive. Fade out.
And don't forget to like and subscribe for next amazing video. Thank you.